everyone! Welcome to my YouTube channel, where math meets fun and curiosity. I'm Regina Insingson, your guide through the fascinating world of numbers and angles. Today, we're going to unravel the mysteries of trigonometry. We'll be exploring the Pythagorean identities, their derivation, and how they sneak into our everyday lives. Ready to embark on this mathematical adventure? Let's dive in! Alright, adventurers, our first step is to the land of Pythagorean identities. These identities are like the hidden treasure of trigonometry, and they come from the famous Pythagorean theorem. The Pythagorean theorem is named after the ancient Greek mathematician Pythagoras, who lived around 500 BC. He discovered that in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of other two sides. This can be written as a squared plus b squared is equal to c squared. Now, let's see how this leads to our trigonometric identities. The identities we'll explore today are sine squared theta plus cosine squared theta is equal to 1. 1 plus tangent squared theta is equal to secant squared theta. Lastly, 1 plus cotangent squared theta is equal to cosecant squared theta. Now, let's begin with the most famous one. Sine squared theta plus cosine squared theta is equal to 1. Picture this right triangle, where the sides are the opposite side labeled as A, the adjacent side labeled as B, and the hypotenuse labeled as C. According to the Pythagorean theorem, we have a squared plus b squared is equal to c squared. Now, here comes a key step. We multiply both sides by 1 over c squared. But why do we do this? Multiplying 1 over c squared normalizes the equation to relate directly to the unit circle, where the hypotenuse c is equal to 1. Now, let us multiply it both sides. Let's simplify the equation by factoring. C squared divided by c squared is equal to 1. Recognize that a over c, or opposite over hypotenuse, is equal to sine theta. And b over c, or adjacent over hypotenuse, is equal to cosine theta. Now, this simplifies to quantity sine theta squared plus quantity cosine theta squared is equal to 1. Then, we're going to simplify. This is equal to sine squared theta plus cosine squared theta is equal to 1. Boom! We've found our first treasure! Now, let's uncover the second treasure. 1 plus tangent squared theta is equal to secant squared theta. Recall these identities. Tangent theta is equal to sine theta over cosine theta. And the reciprocal identity of secant theta is equal to 1 over cosine theta. From the first identity, sine squared theta plus cosine squared theta is equal to 1. Multiply every term by 1 over cosine squared theta. After multiplying, we'll get the answer sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta is equal to 1 over cosine squared theta. For us to get an identity, let's factor out the square. This equals to sine theta over cosine theta squared plus cosine squared theta over cosine squared theta is equal to 1 is equal to 1 over cosine theta squared. Now, let's simplify the equation using these identities. Sine theta over cosine theta is equal to tangent theta squared plus 1 is equal to 1 over cosine theta is equal to secant theta square. This simplifies to tangent squared theta plus 1 is equal to secant squared theta. And just like that, we've uncovered another gem of trigonometry. Finally, let's discover our third treasure. 1 plus cotangent squared theta is equal to cosecant squared theta. Now, recall the quotient identity. Cotangent theta is equal to cosine theta over sine theta. And the reciprocal identity of cosecant theta, which is equal to 1 over sine theta. From our first identity, sine squared theta plus cosine squared theta is equal to 1, multiply every term by 1 over sine squared theta. This equals to sine squared theta over sine squared theta plus cosine squared theta over sine squared theta is equal to 1 over sine squared theta. To form an identity, let us simplify and factor out the square. Sine squared theta over sine squared theta is equal to 1 plus quantity cosine theta over sine theta square is equal to quantity 1 over sine theta, and don't forget the square. In these identities, we can simplify this equation. This equals to 1 plus cotangent theta squared is equal to cosecant theta squared. This simplifies to 1 plus cotangent squared theta is equal to cosecant squared theta. And there you have it, the third of our Pythagorean identities. Example number 1. Find cosine theta if sine theta is equal to 3 over 5 and theta is in the first quadrant. First, let us identify what Pythagorean identity we will be using. In this case, we will use the first Pythagorean identity, which is the sine squared theta plus cosine squared theta is equal to 1. After that, we will substitute sine theta by 3 over 5. Don't forget to write the square, and then copy the rest. Cosine squared theta is equal to 1. Next, we will calculate the 3 over 5 squared, which is equal to 9 over 25, and then copy the rest. To eliminate the 9 over 25 here, we will going to add negative 9 over 25 to both sides of the equation. Cosine squared theta is equal to 1 minus 9 over 25. Let us express 1 as a fraction. This becomes cosine squared theta is equal to 25 over 25 minus 9 over 25. Next, we will subtract the fractions. Cosine squared theta is equal to 16 over 25. Next, take the square root of both sides. Cosine theta is equal to positive negative 4 over 5. Let us consider that theta is in quadrant 1, which means that all the trigonometric ratios are positive. Hence, cosine theta is equal to positive 4 over 5. Example number 2. Find secant theta if tangent theta is equal to 3 over 4 and theta is in the third quadrant. First, we will identify what Pythagorean identity we will be using in this example. In this case, we will use the second identity, which is 1 plus tangent squared theta is equal to secant squared theta. Next, we will substitute tangent theta into 3 over 4. So this becomes 1 plus 3 over 4 squared is equal to secant squared theta. After that, we will calculate 3 over 4 squared. Next, express 1 as a fraction. Next, we will add the fractions. This will become 25 over 16 is equal to secant squared theta. After that, take the square root of both sides. This will be equal to secant theta is equal to positive negative 5 over 4. Since theta is in quadrant 3 and the only positive ratios in the quadrant 3 are tangent and cotangent, secant theta is equal to negative 5 over 4.
Trigonometry isn't just for textbooks, it's all around us. Engineers use these identities to design and analyze structures like bridges and skyscrapers. Pilots also use trigonometry for navigation, plotting their courses using angles and distances to ensure they travel the safest and most efficient route. Today, we've explored the hidden treasures of trigonometry, the Pythagorean identities. Here's a quick summary of the 3 identities we've derived. First, sine squared theta plus cosine squared theta is equal to 1. Second, 1 plus tangent squared theta is equal to secant squared theta. And lastly, 1 plus cotangent squared theta is equal to cosecant squared theta. But don't just take my word for it. Try it out for yourself. Grab a piece of paper, draw some right triangles, and see how these identities work. Challenge yourself with different angles and see the magic of trigonometry unfold. The more you practice, the more intuitive this concept will become. Thank you for joining me on this mathematical adventure. If you enjoyed this tutorial, please like and subscribe. Remember, math is a powerful tool that can help you solve many problems. Keep exploring, keep learning, and most importantly, keep practicing. See you next time. Bye-bye!